Alright, so today we're going to be going over calculating the gear ratio. So I have two gears here. We'll say that the larger gear would be the input gear, and we can we'll say that the second gear, the smaller gear, is going to be our output gear for the sake of this problem. And let's go ahead and say that I counted up the teeth, and for the sake of this example, we'll say that the input gear has 40 teeth and the output gear has 25 teeth. This is not the actual amount of teeth that each gear has, but for this problem we'll use 40 teeth and 25 teeth as our example. Alright, so when we're calculating gear ratio using the amount of teeth that each gear has, we need to remember that the formula we're going to be using is the number of teeth of our output gear in the numerator, and then in the denominator we're going to have the number of teeth of our input gear. Okay, so in this problem our output gear has 25 teeth, so that is going to be going in the numerator for this problem. So I've got 25 and then over, and then the number of teeth of the input gear, and in this problem we had 40 teeth for our input gear, so 25 over 40 is our gear ratio. We now need to simplify this down. So I'm going to try to find the greatest common factor. If I can't find the greatest common factor, I'm just going to find any factor that I could divide the numerator and the denominator by. In this case, I'm going to go ahead and divide by 5 the numerator and the denominator. So I'm going to divide each of those numbers individually by 5. Okay, that way I keep my ratio the same because I'm doing the same thing to the numerator that I'm doing to the denominator. So 25 divided by 5 would leave me with 5, and then 40 divided by 5 would leave me with 8. And then I'll just double check one more time to see if I have any other common factors, anything I can divide both numbers by to see if I can simplify it further. In this case I cannot. So my gear ratio ends up being 5 to 8. That can be written as a fraction, 5 to 8. I also could write it in this format, 5 to 8, or I could write it exactly how I'm saying it, 5 to 8. Okay. Now if I want to know how many times my input gear is going to turn compared to how many times my output gear is going to turn, that's when I now have to take my ratio of 5 to 8 and I have to think about it a different way. I have to think about it in terms of the number of revolutions. When I'm looking at a gear ratio in terms of the number of revolutions, the formula that I use is the revolutions of the input in the numerator, and then the denominator goes the number of revolutions of our output gear. Revolutions are the number of times that the gear turns in a complete circle. One thing you want to note out is when we're talking about the number of revolutions, the input gear is the one that goes in the numerator up top, and the output goes in the denominator, which is different than when you're using the number of teeth. So since I've already calculated the gear ratio using the number of teeth, which was 5 to 8, I'm now going to go ahead and look at the number of revolutions with my gear ratio. So in this case, the input gear is going to turn 5 times, because 5 is in the numerator. So my input gear will turn 5 times for every 8 times that the output gear turns. For every 8 times the output gear turns. All right, and now looking at my original gears, this kind of makes sense because we see that my input gear is a larger gear compared to the output gear. So if I were to turn the input gear 1 full time in a circle, the output gear is going to end up turning more than 1 time around because it is the smaller gear. And I can see that with my ratio of 5 to 8, that if I were to turn the input gear 5 times, then the output gear is going to end up turning more than 5 times, and in actuality it ends up turning 8 times based on what I calculated with my gear ratio. So this particular gear ratio would end up going from a slow rotation in the input to a fast rotation in the output. So from the input to the output, the speed ends up being increased. So this would be a gear ratio that would provide us with more speed. All right, but then remember that the trade-off is when you get more speed, the inverse is you end up getting less torque or less power. So if you had a robot that you wanted to use that was going to go really, really fast, this might be a gear ratio you would like to use, but in doing so, your robot's not going to end up being as powerful as it could be. So you get more speed, but you end up getting less torque, less power.